Hello everybody, this set of notes is going to be about the main types of reactions that we're going to see this year in chemistry. There are other types of reactions. There's some that are like subcategories or special versions, but these are the main ones that we are going to focus on. We're going to focus on 5 main types. We're going to have synthesis, decomposition, single replacement, double replacement, and combustion. And basically everything that we do will fit into one of these categories. The reason these categories are helpful is because it's going to allow us to predict things about the reactions based on some pattern recognition. If you can find the type of reaction, you can follow a pattern and you can figure some things out. For example, if you know the reactants, you'll be able to predict what your products are. Or vice versa, if you know the products, you'll be able to predict what the reactants were. So being able to classify your reaction into a category will let you follow the patterns. We're going to take a quick look at each of the 5 types and I'll show you the patterns that I'm talking about. So for synthesis, we typically say that it's 2 things combining into one. It doesn't have to be 2 into 1. It could be 3 things combining into 2 things. It could be 7 things combining into 3 things. The idea is that you're just going to end up with fewer items than you started with. So I'm going to give you a generic example with X's and Y's. You can see here I've combined my reactants into fewer products. Here's a specific example. We could have oxygen gas combining with carbon to form carbon dioxide. I had 2 molecules on this side, or I guess a molecule and an atom, but you know what I mean. And now I have 1. I had 2 objects. Now I have 1 object. So what you want to look for when you're trying to see if it fits the pattern is, do you have more reactants than products? That's going to tip you off that it's a synthesis. Decomposition is the opposite. Something's going to break apart into more pieces than it started. You can see here we had calcium carbonate. It broke apart, it decomposed into calcium oxide and carbon dioxide. I started with 1 object and now I have 2. What you're looking for to see if the pattern fits is that you have more products than reactants this time. Next is combustion. A combustion reaction is what we call burning, right? Something is burning, whether it's a log on a fire or the gasoline in your car, right? We are combusting something. It's almost always a hydrocarbon. There's very few instances where it won't be. It will be kind of like a random one that you'll see here or there, but for 99% of the time, it's going to be a hydrocarbon. It's mixing with oxygen gas and it forms carbon dioxide and water. So you can see kind of the generic word up here, hydrocarbon, and here's an example of a hydrocarbon. Hydrocarbons can be small like CH4 or they can get pretty big and pretty complicated. Once in a while, a hydrocarbon may have an extra element thrown in. There might be an oxygen or a sulfur or something stuck in there, but what you're really looking for is that you have carbons and hydrogens bound together. Maybe a little something extra, but that's the main point, is the carbon and the hydrogen. What you're looking for 99% of the time is that you have your hydrocarbon with oxygen gas and that your products are carbon dioxide and water. The products are always carbon dioxide and water. If you ever notice, like on a cold day driving down the road, you may see like water dripping out of a tailpipe, right? You might see what looks like smoke. when the water vapor from the tailpipe is hitting the cold air and it condenses and it turns into water, and then you can see it dripping out of the tailpipe. The reason why a fire only burns when there's oxygen present is because that's a requirement of a combustion reaction. So if you take away the oxygen, it can't burn because the reaction cannot proceed. All right, single replacement, we're swapping one element. So if you look in our generic equation, we have an element and a compound. And this element is going to swap places, and now we're going to have a new compound, and we kicked out some other element. So you can see here, we have aluminum with lead 2 nitrate. Because the aluminum likes to make a cation, it's going to swap places with the other cation. If whatever was here was an anion, it would replace the anion. So you just got to make sure you're being, paying attention to that. So the aluminum kicks out that lead. Now lead is the neutral element. It took some electrons with it. And now aluminum, instead of being neutral, it's now an ion. And now that it's an ion and it lost some of its electrons to that lead, now that ion can bond and make a new compound with the nitrate. So what you want to look for to see if it's a single replacement is that you have one element and one compound, and you're ending with an element and a compound, but they're now different. Make sure you're a little bit careful that you remember you can have diatomic elements. Remember, horses need oats for clear brown eyes. If this said F2, well, F2 is an element. It's just a diatomic element. So don't let that throw you off. It would still be a single replacement with a diatomic. Double replacement is when we switch two things. This time you have two compounds, and you're going to make two new compounds. If you notice, I tried to color code these so you can kind of follow it. We started with silver nitrate and potassium chloride. Now they swap places. They swap places, and now we have silver chloride and potassium nitrate. What's tough on these is you have to make sure that if you were writing out your formulas, that everything ended up neutral when you were finished. It's a lot of crossing over for these double replacement reactions. Okay? So two compounds that are ionic, making two different ionic compounds. Just a couple little things, right, for those single double replacements. If you have a cation, you replace it with a cation. If it's an anion, you replace it with an anion. You always need to be keeping track of which things are positive, which things are negative. You don't want two positives together. You don't want two negatives together. You want to have a cation and then an anion, right? Make sure you list them in that order. Cation always goes first. Another big deal that we'll practice a little bit more on the next lesson is that you need new subscripts, okay? When you make a new formula, you take one of each ion and you figure out how many would be needed to make the compound neutral. I'm going to tell you that you're going to do what's called crossover from scratch. You want to make sure that you're always writing a neutral, valid formula. And then the last part, a reminder to be careful of diatomic elements. They're diatomic. You need to make sure that when they're by themselves, they're diatomic. If they're in a compound, then you figure out how many you need and they don't have to be diatomic. But when they're by themselves, you need to make them diatomic. There is a little flowchart you can add to your notes. Some people find that really helpful. you know, if it helps you, great. If you're not a flowchart person, don't worry about it. I'm never going to say like, here's a blank flowchart, fill it out. It's just a tool. If you can print it in color, that's kind of nice because I did color code the ones down here at the bottom. If you don't have a color copy, you can maybe use some highlighters and you could highlight them. I think that helps people with those replacement reactions. Okay. So one thing I'm going to encourage you to do is anytime you're given a reaction to balance, see if you can figure out what type of reaction it is too, even if I don't ask you, right? Do the little bit of just extra mental practice. It's really good. It doesn't have to be official practice. You can just be looking at a balanced equation and saying, oh yeah, that looks like combustion. Oh yeah, that looks like synthesis. Okay? All right, everybody, that's it for that. I hope that was helpful. Bye.